Video 7-1, Significance of Chemical Formulas, Naming Monatomic Ions, Formula Masses, Polyatomic Ions, and Writing Formulas for Ionic Compounds. Okay, so, Chapter 7, we are looking at formulas and chemical compounds. Okay, now, polyatomic ions, the ones that are on your list, make sure you view all the ions that are on those sheets, especially the polyatomic ones and the ones with multiple charges like Fe2+, Fe3+, ferrous, and ferric. Okay, you need to know all of them. So, quick review from what we learned about in previous chapters, molecular compounds and ionic compounds. You need to be able to distinguish between one and the other, because how you write the formulas and how you name them depends on what type of compound you have. Okay, so, ionic compounds, you have simply look at the formula. Do you have a metal with a nonmetal? Okay, if you have a molecular compound, the elements involved in the chemical formula are going to be nonmetals with the nonmetals. The smallest units are not called molecules on an ionic compound. These are called formula units. Okay, it tells you what is the ratio of the ions to each other. Okay, in a molecular compound, the smallest unit is called a molecule, okay, and the formula gives you the actual number of atoms that are in the molecule. Okay, so what's the significance of chemical formulas? Okay, formulas, if you have subscripts in the formula, it refers to the number of atom or atoms that come before it. In other words, XAYB, the B refers to how many of the Y's you have, the A, how many of the X atoms you have in there. Okay, if you had something like this, X, Y, Z to the B power, the B applies to both Z and Y that's in there. Okay, so Al2SO4 3. Okay, what's there? Okay, the 2 applies only to the Al. The S applies, the 3 applies to the S. The 4 applies only to the O, but so does the 3. It also applies to that too. So multiply subscripts. Okay, if you have subscripts inside the parentheses and outside, you multiply them together. Okay, so what's here? Al should have 2, S should have 3, and the number O's in this formula is going to be 12, 3 times 4. Okay, now, again, stop this, make your guess, and then come back to the video. How many H's are in this formula? NH4, 2C2O4. You're only looking for how many H's. Okay. When you're ready, stop it. When you're ready, come back. Correct answer should be 8. 4 times 2 there. Okay. Now, naming monatomic ions. Mon, or mono, just means one. So, these are ions that are only made up of one atom. Okay. In other words, not the polyatomic ones. Okay. So, all the group A, okay, basically remember this is group 1 through 8. Okay, all the monatomic cations, though, the cations were basically only groups 1 through 3. Okay, simply name the element and then add the word ion to it. Okay, so an example. This was sodium. Since that sodium ion is just called, simply name the element sodium and then ion. That's it. Okay. Now, for anions, don't forget, anions are your negative charges. Okay. All your anions must end in "ide," okay, if they are monatomic. Okay. And you do not just add the word "ide" to it. Most elements will lose a significant amount of their name. So sulfur does not become sulfuride, it becomes sulfide. You drop the UR part. Phosphorus does not become phosphoruside. You drop all of this, ORUS, and then you add the "ide" to it. Oxygen is not oxygenide, but you drop all that, whoops, and the Y, and it becomes oxide. Okay, now, we can also use something called the stock system. Okay? The book will say use the stock system for every positive charged ion, but Okay? We are only going to use it for the ones that have multiple charges on them. So in other words, if it was sodium, because sodium is only one possible charge, we would not use the stock system for it. Okay? Now, what do? We use a Roman numeral. Okay? What's the Roman numeral? Where's it going to come from? It's the value of the charge. Simply that. So, the sodium ion has a 1 plus. If we were going to use the stock system, we call it sodium Roman numeral 1. Okay, where that comes from, that number right there. But because sodium only has one charge, we're never going to call it sodium 1. We're just going to call it sodium. So we only use it for the ones with multiple charges. Okay. So in other words, here's a couple examples. Okay. Iron ion has Fe2 plus, Fe3 plus. This was ferrous. This one is ferric, Fe3 plus. In the stock system, it's called iron 2 or iron 3. Okay. Now, when you name compounds, you can use the stock system if you want to, but make sure you know that iron 3 is ferric and iron 2 is ferrous, because if someone tells you the name of ferrous and ferric, you need to know which charge goes with which name. Okay. Ag1 plus, silver, is still called silver because silver only has one oxidation state, only one charge to it. Okay, there's only one silver ion. Lead was another one that was 2 plus or 4 plus, plumbus and plumbic. So this is lead 2, this is lead 4 because of the Roman numerals going with the same as the charges. Okay, now, formula masses. Don't be confused with the term formula mass. This is basically the exact same thing as the molar mass. Okay, it's the mass of an atom, or sorry, it's the mass of a molecule or a formula unit, but just one of them. This is for 1 mole. This is for one of these units. Okay, it is exactly the same as the molar mass. The only difference is the units will be different because you calculated exactly the same. If I ask you what is the molar mass of XAYB, you look up the molar mass of X, multiply it times A, then you'd add to it the molar mass of Y multiplied times B. Okay. Now, if I said go find the formula mass, you do the exact same thing. You look up the molar mass of X times A multiplied by the molar mass of Y times B, except the units would be in AMUs. Okay, so the numbers will be exactly the same. The only difference is the units are different because you're calculating different quantities. Okay, now, polyatomic ions. Okay, for polyatomic ions, again, the name poly means many, so 2 or more atoms and the charge applies to the entire species. Okay, some naming rules. Some of these you guys already know. Okay, these are not necessary for the polyatomic ones, but these are for the ones with multiple charges. If you have the ones with the ik and the us, the ik is always greater or larger, but that it does not mean that they're always the same charge or that they're only one larger. Okay, but ik is always bigger than the us. Okay. Ferric, Fe3 plus, ferrous, Fe2 plus, but don't forget, cupric is 2 plus, cuprous is 1 plus. Okay, so they're not, the ik is not always the same charge. Okay, and plumbic is Pb4 plus, plumbus Pb2 plus, so not necessarily only one larger. Okay, now for anions, you're going to learn a whole bunch more anions based off of this one ion right here, the one that ends in 8. Okay, now there is a relationship between some of these. If you have an anion name and it looks almost as the 8, but it ends in ite instead. What's the difference between the 8 and the ite form? It's the same in terms of the number of oxygens in the molecule. Okay, all of them will have the exact same charge. Now, if you had one with one less oxygen than the ite, you put a hypo in front of the name, and it's called hypo something ite. If you have an anion that has one more than the 8 form, it's called per 8. Okay, notice the endings though are still only 8s and ites. Okay, so here's an example. Okay, ClO minus, ClO2 minus, ClO3 minus, ClO4 minus. Okay, which one of these was on the list that you're supposed to know? This one right here. This one was called chlorate. Okay, now according to the thing up here, if it has one less oxygen, and notice the charge is still the same, -1, we keep the same root, chlor, but instead of 8, it's called ite. So ClO2, this is chlorite. Okay, now, if it has one less than the ite form, this is called hypochlorite. Okay, the roots are all going to be the same, chlor, chlor, chlor. And this one right here, O4, has one more than the 8, so this is called perchlorate. Okay, they all have the exact same root. Now, okay, you've never seen any of these before, but Br is in the same family as chlorine, Cl. So ClO3 was called chlorate, so this one right here is called bromate. Okay, so if you know chlorate, you should know bromate. Now, the rules still apply. Okay, one less O2 than O3, this is called bromite. One less than that, you put hypo in front. Okay, and notice the ites stay the same. Okay, 8, one more in the 8 form, you put a per in front. Okay, so perbromate. So from chlorate, you learn basically, from this one right here, you learned 1, 2, 3, 4, 5, 6, 7 more. Okay, now be careful. Not all 8s will be able to do all these forms. Okay, some of them will just be able to do the ites, but not all of them will be able to do hypobromite or perbromate. Okay, now we did Cl, we did Br, F does not do anything. I does the same thing as O. So if I gave you IO3 minus, it's the same just like the chlorate and the bromate. This is called iodate. Okay, so you should be able to do IO4 minus, IO2 minus, and IO minus, based on the rules, the exact same rules that we had for the bromates and the chlorates. Okay, so stop this, take your guess, come back. Which of the following is the correct name for SO3 2 minus? Okay, you should know that this looks like sulfate, but sulfate, again, you have to be able to recognize your ions by charge. SO4 2 minus is sulfate. So this is one less, so this is sulfite. Okay, what's the formula for phosphite? Again, pause it, take a guess, and come back, check. Okay, you see the name phosphite. That wasn't on your list, but the one that you do know is phosphate. Okay, and phosphate's formula, you need to know all these again. PO4 3 minus, so the ite must be one less, so it's going to be PO3 3 minus. Okay, and remember the charges always stay the same. Okay, now a couple more. Okay, you may see the name hydrogen something or bi something ions. Okay, this is basically made by combining an H plus ion with a ion that is -2 or greater. Okay, but only one of the H pluses get added on. And the plus charge changes the minus charge by 1. Okay, so an example, HCO3 1 minus. This compound is called either hydrogen something or bi something. Okay, what is it? Well, you look and see. CO3 2 minus is the one that you know, which is carbonate. So this ion is called either hydrogen carbonate or bicarbonate. Okay, now, why is it 1 minus? Because you took that and you combined it with an H plus charge. These add up together and turn into a -1 charge. So when HCO3 combines with it, the charge goes down to -1. Okay, so this is called hydrocarbonate or bicarbonate. Okay, so which one of these is the formula for bisulfite? Okay, again, stop, make your guess, come back. Okay, bisulfite, you need to know what sulfite is. Sulfate is SO4, 2 minus, so sulfite must be 1 less, SO3, 1 minus, or 2 minus, same charge. Now, you put the H in front, but it's an H plus, so the charge will decrease from -2 down to -1. Okay, and it's going to be this one right here, HSO3, 1 minus. Okay, now, writing formulas for ionic compounds. Okay, if you are given the name of an ionic compound, you need to follow these rules. Okay, write out the formula for the cation. The first name of the ionic compound is the cation. It's not going to tell you the charge, so you need to be able to figure it out from the name. Okay, the second name is the second ion. There can only be 2 ions in your polyatomic ion. Okay, so write it out. What's the formula for that ion with the charge again? Okay, now the positive charges must cancel out with the negative charges. Okay, if they don't, if it's x2 plus and y3 minus, adding the charges don't cancel out. If they don't cancel out, you need to crisscross them. In other words, this becomes the subscript for the anion. That becomes the subscript for the cation. Okay, and get rid of the plus and minus charges. Ignore those. Okay, and the formula has to show you the lowest ratio. If it's 2 to 3, that's the smallest. If it were x2 plus y4 minus, okay, you'd crisscross it, and it would be x4 y2. That's not the smallest ratio. 4 to 2. You can reduce it down to 2 to 1. Okay, and if there's a 1, you don't write a subscript. If there's no subscript, the subscript is 1. Okay, and you cannot change the formula for any polyatomic ions. If you need more than one of them, use parentheses. The way you can tell there's more than one polyatomic ion in the formula is you see parentheses. Okay, so let's try one out. What's the formula for aluminum sulfate? Okay, so the first one is your cation, always, and the second one is always the anion. Okay, so we don't write out the formula for aluminum, we write out the formula for the aluminum ion, which is Al3+. Okay, if you forget some of these, you can use the periodic table to help you. Okay, sulfate, you have to memorize this. SO4, 2 minus. Okay, plus 3 minus 2, charges don't cancel out. So, crisscross. The 3 has to become the subscript for the sulfate. 2 becomes the subscript for the Al. So, Al2. Now, it's a polyatomic ion. I need 3 of them. You must write it in parentheses and then put your subscript outside of that. Al2, SO4, parentheses 3. Okay, so, again, do this one, pause it, do this one, come back, check your answer. Okay, so calcium chromate, our 2 ions must be Ca2+, and chromate, CrO4, 2 minus. Okay, now, what happens if the charges are exactly the same and they cancel out? You ignore them and just put them together. So the correct answer should be CaCrO4. Simple as that. Okay, again, pause this one, come back when you're done. What's the formula for ammonium nitride? Okay, again, need to know your ions. Ammonium, NH4, 1+, your polyatomic ion. Okay, and nitride is not one of the nitrates. Ide almost always means it's monatomic, so that is the nitrogen ion. It's N, and if you remember it's column 3, 3 minus. Okay, so again, crisscross your charges, that goes there, that becomes a subscript for that. So we need 3 ammonias and only 1 nitrogen. And because that's a polyatomic, you need to use parentheses. Okay, so the correct formula should be this one. Okay. Cupric oxalate. Okay, again, pause, come back when you're done. Okay, cupric, this is the bigger copper ion, but remember copper is only +1 or +2, so cupric is +2. Oxalate, a lot of you had problems with this one, you got to memorize it. C2O4, and the charge is 1-. Okay, so crisscross, oops, sorry, charge is 2- on oxalate. Okay, so we don't need to crisscross because it's +2 -2, so cancel it out. Okay, and it should be C2O4. You just put everything together. Okay. Sodium perchlorate. Again, pause and come back. Okay, so sodium ion, Na1+. Perchlorate. This is one that you just learned about. Perchlorate is ClO3 1-. So per must be one more. ClO4 1-. Okay. Pluses and minuses cancel out. We don't need a crisscross, so it's simply going to be NaClO4. Okay. Ferrous hydroxide. Okay, ferrous. Whoops. Fe2+ hydroxide OH-. Okay. 2+, 1-. Crisscross. Okay. And be careful, for some reason, a lot of people don't use the parentheses and they pick this one right here, which is not correct. The correct one is this one down here. You have to use the parentheses around the polyatomic ions. Now for review. What is the name of IO4 1-? Iodide, iodite, iodate, hypoiodite, or periodate.